if everybody would look with me at this here, and if you look at the very top, it tells you a little bit about what you've got to do. You've got to draw a picture, okay? And your picture has a few parameters to it, and I've kind of outlined the parameters right here of exactly what your picture should be. Now, on the back of this, if you would flip this over with me, I showed you a couple examples of what students have done in previous years, okay? You're not looking at the right thing. Okay, so on the back of this, you can see what one person did. They did a 44 with like a cross around it like that. You notice they only use straight lines. There's a reason why they only use straight lines. They only use straight lines because we've only studied linear stuff so far. We haven't done any of the curved stuff so far, like exponentials or quadratics or anything like that. Okay, so they use straight lines. So they've got a bunch of straight lines on here. On the very front of your paper, it said that you have to have at least 10 positive slopes, 10 negative slopes, 5 slopes of 0, and 5 slopes that are undefined, at least that much. I want to point out kind of what those are right here. Positive slopes are in the back, are as if you walked across your paper from left to right. A positive slope would be if you hit a line and you're walking uphill. So like this line right here is a positive slope. That one's positive. So is this one. So is this one. It's on a slant, but it's like it's uphill. If you look at the second one here, this person did a Kansas Jayhawk. This person was a big Kansas fan. And when they did it, I want to show you the ones that are negative slopes. Right here, this is a negative slope. As you're walking across the paper, if you hit that line, you'd be walking downhill. Same thing here, same thing here. So you'll need at least 10 with negative slopes also. Okay? Now on the front then it said some with slopes of 0. Well, a slope of 0 in the classroom, the floor has a slope of 0. It has no slope at all. When you walk on the floor, it doesn't feel like you're walking uphill or downhill. So ones on here that would have a slope of 0 would be like right here. The flat ones. This would have a slope of 0. So would this one. There's other ones also that are like flat. Okay, those would be the ones with a slope of 0. So right here, anything that's flat, those would be a slope of 0. And then also it asks for slopes that are undefined. Slopes that are undefined, the wall has a slope that's undefined. It's straight up and down. So anything on here that's straight up and down would be a slope that's undefined. So that kind of gives you some parameters to what kinds of lines do you need to use. Now what I want to do is I just want to talk to you about all of these equations that you see and make sure you know how to do that. This should be a good review of the entire unit. Can everybody take their blank piece of paper here that you had? Not the one on the front here, the blank one. And can everybody take a ruler? And let's put our X and Y axis on here. Try to do it about in the middle. About in the middle. Okay, so it looks kind of like that. Okay, so can everybody get their setup like that to start? And then all I want you to do is I want you to go 12 in all directions to start, okay? So can you start by going 12 to the right, 12 up, and that's just every box that's make worth 1. But you don't have to put a number on every one if you don't want to. Watch what I'm going to do here. Like when I go to the right here, I'm just going to go, this is 1, this is 2, 3, 4, just so mine's not quite so messy, 5, 6, 7, 8. If you want to save yourself some time, feel free to do that, okay? And that's the x-axis. Now, you can label every single one if you want, but you don't have to. But I do think we should just go by ones, and let's go to 12, okay? And then when we go up, let's go to 12 also. So here's 1, 2, and this is our y. And then we'll do the same thing, the negatives and the negatives, so forth to the left here. So our negatives to the left. You know, and I just went to negative 12. And do the same thing then going down. And just to negative 12, okay? All right, so your entire paper then looks like this. And what I'm going to do with you is I'm just going to do 4 examples, since when you guys come up with your design, you're going to have 4 different types of lines. Right? You're going to have positive slopes, negative slopes, slope of 0, and slope of undefined. So I'll just show you those 4 things. We're going to do each one of the examples in a different quadrant here, okay? So we're going to start in quadrant 2. And I'm going to show you exactly how you could do this, and I think it's going to become really clear to you. Can everybody start right up here in quadrant 2? Let me make this a little bit bigger for you. By just writing these coordinates, can you write negative 3, 7, and can you write negative 8, 2? Okay? So put those up there in quadrant 2. Now, if you'll notice my examples on that other page, I'll show you that first one again. You see how this person, there's a bunch of dots on here. See how the lines don't go forever? So there's like a dot at every coordinate. And so all they did is they had 2 coordinates, and they just took those 2 coordinates and they wrote an equation. We've practiced that a bunch. I'll show you what I mean on this. So I just gave you 2 coordinates. Let's plot those 2 coordinates, okay? Negative 3, 7, negative 3, 7. Negative 8, 2, negative 8, 2. Okay, so your 2 dots should look just like that. Can you go ahead and connect those with a straight line? Now, when you do this project, once you draw a line, you've got to write the equation that matches the line. Just like these other people did, you can see they've got their lines, they've got a bunch of equations written. Right? They've got an equation for every single line. So we're going to do the exact same thing. So I think I've been teaching you, take your points and put it into a table. So right underneath here, can everybody go ahead and put these into a table? Negative 3, 7, negative 8, 2. And from our table, we should be able to write a function that matches our line. Go ahead. Negative 3, 7, negative 3, 7, and negative 8, 2. Okay? And then I just connected them. So when we do this, if we're going to write our equation, we know we always start with the deltas. So do the deltas on both sides. And I think if you do it correctly, you get negative 5 over here, and you get negative 5 over here. Okay? What am I supposed to do with those 2 deltas? Divide them. When I divide them, negative 5 divided by negative 5, my slope would be 1. Okay, now here is where you've got to think back to everything we've done in this unit. Now that you've got the slope, You've got to think, what's the most efficient way to write the equation of this line? Should I use slope-intercept form? Should I use point-slope form? Or should I use standard form? Because we've learned 3 different forms. Does anybody know what you would use on this one? What would probably be the smartest one to use, the most efficient? Negative 3x plus... No, the standard form would mean you have the 2 intercepts. Do we have the 2 intercepts? No, we don't. So let's not use standard form. Okay, point slope, I think, is the right one to choose because we don't have either intercept, but we do have a point. So let's pick one, and let's write it. I'm going to pick the bottom one here, and I'm going to write my function. Remember how we write a function? We would just write y, and we would look at the y and say, how do we get that back to 0? We would subtract 2. We would write equals. We'd write our slope. And then we'd write our x, and we'd say, how do we get this x back to 0? We would add 8, because it's a minus 8 right now. If you want to leave it just like that on your line, you can leave it just like that. Or we can do the drag thing and say this is really y equals 1, x plus 8 plus 2. Either one of these is okay. You can leave it either way. Now this would be an example of a line with a positive slope. So right here, can you write positive slope? There's a bunch of ways you can tell this has a positive slope. The m is positive, that is the slope. But also the line, if you walk across your paper walking left to right, if you hit this line, you'd be walking uphill. Anytime you're walking uphill, it's a positive slope. When you make your design, you need to have 10 lines that have a positive slope. That's what it means on the very front of this when it said at least 10 lines with a positive slope. Okay? Can everybody move to quadrant 1? Quadrant 1 right here. And can you write down these 2 points? 0, 10 and 4, 3. Okay? Those 2 right there, 0, 10, and 4, 3. Let's do the exact same thing we did before. Let's plot those 2 points. So we'll plot those 2 points, 0, 10. 0, 10 is right here. 4, 3. 4, 3 is right here. Okay? So we've got our 2 points there. Can you connect those with a straight line using your ruler? And there is our line. Okay? Let's do the same thing we did before. Let's write an equation for this line using a table. So can you take what we just did and put it into a table? So x and y. So we'd put 0, 10 and 4, 3. And we'll do the same thing. We'll do our deltas. We'll decide which form to use. So we'll do our deltas. This side would be negative 7. This side would be a positive 4. So our m, we're going to divide those. Now, when you divide negative 7 divided by 4, you end up getting like negative 1.75. If you get a weird decimal, now that one's not that bad, but sometimes when you divide these, you guys are getting really long decimals. If you get a really long decimal, just leave it as a fraction. Don't even divide it. So let's just say our slope here is negative 7 over 4. And let's just leave it like that. Negative 7 over 4. Okay? Now looking at this, you have to make the decision about which form to use. See how I have the y-intercept. So I think the easiest one to use would be slope-intercept, since I've got the y-intercept right here. So I think the easiest way to write this would just be y equals, we've got our slope, negative 7 over 4x, and we've got our y-intercept, so I'm just going to write plus 10. And that's our equation for that line. Now, if you wanted to do it the exact same way we did the other one and pick a point and plug it in and all that you could. But if you're given the y-intercept, you might as well take the path of least resistance, right? You might as well take the most efficient way. This is an example of one with a negative slope. Can you write that right here? A negative slope. You need to do 10 of those when you do your project. 10 of those. And you can see what these other people did in previous years. It would be nice if it looked like something. Yeah, it'd be nice. It'd be more interesting for me to look at anyways. And you can see all these different, you can see the positive and negative slopes there, and you can see the positive and negative slopes, in that one too. Okay? Go ahead. We'll see. I'll show you just a second. Okay? All right, can everybody slide to the third one right here? I guess that would be quadrant 3. And let me show you. Now, we've done, once you do those 10, what's that? We are in quadrant 3. Yes, we are. The last two are kind of easy to do. Watch, can you make this, plot these 2 points? Except when you plot these two, well, I guess we'll make it a little bit lower. Here we go. Can you write this one? -8, -10. -8, -10. And can you put -12, -10? So those are the 2 points I want you to plot. Okay, so let's go down and do that. -8, -10. Put a dot right there. And -12, -10. -12, -10, let's put a dot right there. And then just connect those with a straight line. Now that one is flat. And just like I said at the very beginning, so that one, if it's flat, it has a slope of 0. So right away, just by looking at this, we know the slope is 0. Right away, we know the slope is 0. The floor has a slope of 0. When you walk on the floor, hopefully it doesn't feel like you're walking uphill or downhill. It feels like it's flat. The slope is 0. If you know the slope is 0, we should use this. Can you write this with me? Y equals mx plus b. Y equals mx plus b. And I'll show you a real quick way to do these. Because our slope is 0, we would put 0 in for the slope. If we put 0 in for the slope, 0 times x is just going to be 0. It's going to cancel out. It's going to go away, this part of it. And all we're going to have left is y equals b. Well, what is y equals b? B is the y-intercept. If you would go back to your line, and if you would continue your line with a dotted line across until you see where it's going to hit, it's going to hit right at -10. And so we could easily write the equation for this. It is simply y equals -10. There's no slope part to it. The slope is 0. So your equation is just y equals -10. I've now done 3 of them. We've done the one with the positive slopes. Everybody listen. We've done the one with the negative slopes. This is one with a slope of 0, so I'm going to write that here at the bottom. You should do the same thing, write the slope of 0. Okay? All right, so we've done those. Let's do our very last one here. Okay? And this is again going to be, this is when our slope is undefined. So can everybody move to quadrant 4? And in quadrant 4, can you write down these points? Write down 6, -4. And write down 6, -8. Stay with me here, everybody. Okay? That is -8, yep. Okay, so 6, -4 and 6, -8. So 6, -4, let me go to that one and put a dot. 6, -8, Let me go to that one and put a dot. Connect those with a straight line. That is like the wall. You know, that is undefined. This one's going to be a slope. The slope is undefined. Can you write that? You need to do 5 lines that are straight up and down. Well, how in the world do we do an undefined one? I want to show you something on your calculator. Start by putting this into a table. So here's our x, here's our y. Do 6, negative 4, and do 6, negative 8. Okay, can everybody write that table there? And let's find the equation by doing the deltas and dividing like we always would. If you do negative 8 minus a negative 4, I think you get negative 4. And if you do 6 minus 6, I think you get 0. And then we're supposed to divide those to get our delta. Can everybody go ahead and divide those a second? Everybody do this on your calculator. Yeah. Is that right? So it's going to be 0, right? Is everybody good with that? Is that what it says? That it's 0? It does? What's it say? It says error. When you did negative 4 divided by 0, it should not say 0. It should say error. Your calculator is saying, if you divide something by 0, and students get confused about this a lot. Think about it this way. If I have no money on me, I've got no money on me, and I'm going to divide it between everybody in the classroom. So I've got no money, and let's divide it by 30. How much money is everybody going to get? 0. So 0 divided by 30 is 0. 0 divided by, but what if I had $30 on me, and I want to divide it amongst 0 people? I don't even want to keep any. I just want all of a sudden $30 to disappear. That you can't make stuff dividing by 0 is making stuff disappear. And you can't make stuff disappear. You know, so you can't divide by 0. You can't break something into 0 groups. It's always in at least one group. It would just, so dividing by 0 isn't okay. You can't, and that's why your calculator is going, I can't make stuff disappear. I don't know what to do. When your calculator gives you an error, what your calculator is trying to tell you is that it's undefined. Can you write undefined underneath that? So how in the world can we do this? Well, this is how we can write an equation instead. Watch. Can you draw your dotted line just like we did on the last one? Draw up until you hit the axis. I just hit the x-axis. So my equation is going to be x equals 6. And if you look closely on the other side here, you'll notice, see the lines that go straight up and down and see the lines that go straight across. Like if I put this one up, see this one that goes straight up and down? See how that says x equals negative 9? See how this one says y equals 4? This one says y equals negative 1. This one just says x equals negative 3. So you can see they did that part correctly. When you are done with your quiz, you are going to start sketching an idea, and the reason what other people in my first hour did is they did this. And so you've got this piece of paper that you just did notes on. They flipped it over and they started like sketching some ideas before they put it on here, the final copy. So you should do that same thing also. Sketch a few ideas and then you can get started on this. You're going to have about probably 15 minutes today and you'll have time tomorrow, and I think this should be done on Monday. Okay? All right, I think we're ready to put that off to the side, and I think we're ready to take